Welcome to this session. That's day number 22. That's 6th of May 2025. Welcome to this session. I hope everyone's doing absolutely fine. Today we are going to be discussing on cross products associated with vectors. So are we ready to do so? I hope I'm audible to everyone. If yes, give a thumbs up and let's start this session accordingly. Am I audible, everyone? Okay, so today, before we initiate the session, I would like to say about certain things. One question was supposed to be solved, isn't it? So let's try to solve that question, everyone. So you can see that this is also a PYQ. Before we start cross products, this is an application part of dot products, where they are given us what will be the projection of A vector on vector B is equals to I cap plus J cap. So what needs to be done? So this is an application of dot products itself. So you can write down the concept which is going to be included over here, that is projection of A vector on B vector can be determined by using A dot B is going to be equivalent to AB cos theta. Everyone knows this. So what are we supposed to find out? We are supposed to find out A cos theta over here. So you can write down that A cos theta is going to be equivalent to A dot B divided by B over here. So that's how you can find the value of it, isn't it? So now you should not be asking this, so you can focus over here. So in this question you are being given to find out the projection of this on vector B is equals to I cap plus J cap. So what needs to be done over here? You can see that, just try to perform A dot B, everyone. That is A dot B is going to be equivalent to I cap plus J cap plus K cap dot I cap plus J cap. So can you find out the dot product in between these two vectors? You can write it down over there in the chat box. So what do you think it's going to be, everyone? Can you write down the value over there? I'm waiting for the value to be written. I cap plus J cap. I'm asking you to find out the dot product in between them, everyone. So I hope I'm audible to everyone, right, isn't it? And so it's going to be 1. That's correct. So you can write it down over here as 1. You know that I cap, yesterday itself we discussed about this, as you can recall. I cap could be undergo with the dot product process only with the like unit vector itself. So I can write it down over there as I cap dot I cap is 1 plus J cap dot J cap is 1. So as a result I will be getting it as 2. 2 is going to be the dot product associated in between them. So now we are able to find out the magnitude of A dot B. Now the projection is going to be on this vector, isn't it? The projection is going to be on that vector. So now we have to find out the unit vector associated with I cap plus J cap. So what we are going to do is, we can say that this value which we are obtaining over here is equivalent to 2. So you can write it down, everyone, that is unit vector associated with what we are going to say, I cap plus J cap is going to be equivalent to I cap plus J cap by square root of 2, isn't it? That's what is going to be our value. And we already know the magnitude of this, which is already we got it as 2, and the magnitude of it is already root 2 over here, isn't it? So now the projection, you can write it down it as 2 into I cap plus J cap. So actually you got the dot product over here. What is going to be the magnitude itself? You can say that's going to be root 2 itself by root 2. As a result, what I will be getting, this is going to be written as 2 into I cap plus J cap by 2. 2 gets cancelled out. So as a result, I will be getting I cap plus J cap to be the correct answer amongst our given list of options. So that's how you can find out the projection on one vector on the other. So once again I would like to say, find out the dot product, isn't it? So we are able to find out this A dot B. This A dot B is successfully calculated over there. But now you need to find out this. Already A dot B by B was there, right? So that's why I wrote down this is nothing but A dot B by B. This is what the value was, 2 by root 2. And now nextly what you had to do? You had to find out the unit vector associated with B vector, because they're asking you to find out the parallel projection of that vector which is being mentioned as A on this vector, which is I cap plus j cap. So as a result of that, you will be getting it as I cap plus. So what I did, this value, the magnitude I found it, isn't it? This A cos theta you found it out, and then I just tried to multiply it with the unit vector associated with the B vector over here. So as a result of that, I will be getting the projection of A vector on B vector. So this is what the parallel projections are all about. If it is clear to everyone, give a thumbs up, hit the like button, and if you have any doubt as such, you can ask it from me. So I hope it's I cap plus j cap, everyone's getting. So now let's start with cross products. That's a very important topic in order to understand rotational mechanics, the concepts of rotational mechanics. Everyone needs to be aware about cross products. So now let's try to start cross products, everyone. Okay, so are we ready to understand cross products? So let's get started with cross products. Yesterday, if you can recall, one question we already solved which included the concept of cross products, isn't it? A cross B is AB sin theta. So that's what we would like to find it out over here. Okay, thank you, Ramu. Okay, so now you can write down vector product of two vectors. That's the today's topic, vector product of two vectors. So you can see that projection, Rajeshwari. Projection means the component of one vector on the other. So there are two types of projection. One is parallel projection and the one is perpendicular projection. So that's how the one which I found it over here. This is actually the parallel projection which you obtained it over here. And you can similarly find out the perpendicular projection by just subtracting this vector with the x component. Okay. Perpendicular, you know that A vector can be written as what? A parallel plus A perpendicular, isn't it? So that's how you calculated the perpendicular projection over here. But suppose parallel projection over here, suppose you are being asked to find out the perpendicular projection, that is going to be A vector minus of A parallel. That's what is required to be done over here. So now as a result of that, you will be getting it as what? So A vector, we were already having it as I cap plus j cap plus k cap, isn't it? And what is the parallel component? I got it as this is the parallel component, isn't it? This is the parallel component. I believe that everyone knows the concept of parallel component, everyone. So now minus of this we just have to do, that is I cap plus j cap. So if I solve it, I will be getting the perpendicular component to be k cap itself. So I cap plus j cap is the parallel component and k cap is the perpendicular component over here in this question. So I hope the person who asked me this question, it's clear to you. So now let's try to solve the other question over here, means not the question. Now let's start the concept for today. So what is the definition? The vector product or cross product of two vectors is defined as a vector having magnitude equal to the product of their magnitudes with the sign of angle in between them. So what does it mean? They're just trying to say that now in the previous class, if you can recall, I tried to perform the dot product by mentioning A dot B, isn't it? So now in this context, we are going to be using a different symbol, a mathematical operation over here, that is cross. So that's why I would like to write it down over there as A cross B is going to be equivalent to AB sin theta. That's what they're trying to say. You can mark this as a very important equation, and I think so I already used this equation in the previous class, if you can recall. So A cross B is nothing but AB sine of theta. What are A and B? A and B are the magnitudes of, you can say that this is a very important equation, of 1000 stars worth, isn't it? And what are A and B? A and B are nothing but the magnitudes, isn't it? These are the magnitudes of A and B. That's what it's being said over here. So, and its direction is perpendicular to the plane containing both the vectors according to the right hand skew rule. So, I will mention about it. It's there. The topic of discussion is there in the upcoming context. Okay. So, I hope everyone's following me. I hope everyone's following me, right? So, there's no point of chatting amongst yourself. Okay. So, now as a result of that, what we can do? So, you can say that both the vectors according to the right hand skew rule or right hand thumb rule. That's what it's being given. So now they are saying that A, B are two vectors, then their vector product A cross B is a vector C. So I can write down, this is what the expression which I tried to mention over here. The same expression is being given over here, that is C vector is equal to A cross B is equal to AB sine theta n cap. N cap is what? N cap is the unit vector associated over here. Okay. So now let's proceed. I think so this is clear to everyone. A cross B is AB sine theta. This is what you need to recall. Okay. So now the most important aspect in this context is to how to find the cross product. Dot product was very easy, which we have already seen in the previous class, isn't it? So today what are we supposed to do? So now you can see that this is how the representation of C vector means. So now in the previous class, if you can recall, I said that if I try to perform the dot product of A and B, the quantity which I will be getting as a result of it will be a scalar quantity. Scalar quantities means those which will be only associated with magnitude but no direction. But over here in this context, we are going to be having a vector, okay, A cross B is equal to C vector, where C vector is a vector itself. So that's what I'm just trying to say. So now you can see over here, place the vector A and B tail to tail, just like the way they have shown over here. You can see, right, everyone? There are two vectors A and B, they are being placed tail to tail. And the tails are coinciding with respect to each one of them, just like the way I've drawn over here, isn't it? So now A and B such that the fingers are along the vector A, isn't it? So now if the fingers are now close through a smaller angle such that it goes towards B, then the thumb gives the direction. So now you can see that it's all about the sense of rotation. You can see that the sense of rotation is anti-clockwise. Everyone knows anti-clockwise and clockwise, isn't it? So this is what we are trying to do. We are just trying to, from A to B, we are trying to curl our fingers. So I will try to draw it over here, everyone. What is this corkscrew rule? So just, this is what I am trying to draw. This is my right wrist. Okay, everyone, this is my right wrist and this is the thumb. So obviously I'm just trying to draw the logo of thumbs up, isn't it? This is what I'm trying to draw. I think so I have been asking you all to give me a thumbs up, isn't it? So that's what I'm just trying to ask you. The same thumbs up over here I'm trying to draw. This is what the representation of Maxwell's corkscrew rule is all about. So now that's how it looks like. Okay, so over here you can see that the curl of your fingers is going to be along the direction of rotation. If I say that something is rotating in an anti-clockwise direction, isn't it? So what I have to do is, we need to draw it like this, because obviously from your camera point of view, this is going to be clockwise, isn't it? So that's why what I'm just trying to say, that that's how I'm just trying to rotate it over here. So now the thumb is going to be denoting the direction of the vector, the rotational vector, like torque, angular momentum, angular impulse, isn't it, if you can recall. So now I have already mentioned about this, if you can recall, about a type of vector which we discussed about it, isn't it? Can you recall, everyone? Okay, very good, Akshat, if you have studied in class 10th ICSE physics. Okay, so this is what we are just trying to say over here. So this is going to be the direction of rotation, and the thumb is going to be denoting the direction of torque vector. Okay, you can write down the terms: torque vector, angular momentum, angular velocity, isn't it? Angular momentum. So this rule is going to be taught in rotational mechanics as well by your respective sirs and madams. So that's why I am mentioning to you all right now at this moment itself, such that at that point of time you don't face any sort of difficulty. This is what I am trying to say. So angular momentum, angular acceleration, isn't it? Then angular velocity, etc. So now in this context, they are just giving you that C is an arbitrary vector and it's the cross product of A and B, isn't it? So you can see over here that the sense of rotation in this plane, this is a plane, right? We are talking about this plane, everyone. So in this plane, we are able to see that the angle of rotation is anti-clockwise and the C vector is above, is plane perpendicular to that system comprising of two vectors. I hope everyone is able to observe this. This phenomena is really interesting. Okay, everyone. So I think so it's clear. So you can see that's how they are denoting the direction of this n cap, which is being given over here. Okay. So that's what is thumbs up means. If you're able to understand the thumbs up concept, then give me a thumbs up and hit the like button as well. Okay. So that's what I'm trying to say. This is C is equals to A cross B, which I'm trying to mention it over here. Okay. So now you can easily try to find out the direction of torque, angular momentum. You can just try to check it right away itself. If by chance, obviously most of you people must be sitting in an AC room right now and watching me in front of you. But let's say if anyone by chance might have turned on his or her fan, you can just see the sense of rotation of the fan and try to curl your fingers accordingly and determine the direction of angular acceleration and torque. Okay. So I hope it's clear, everyone. So now let's try to proceed to the next concept over here. Right hand screw rule. This is what I was trying to say. So you can write down this in the form of a note, that this is what is known as right hand screw rule. The one which I mentioned, this method is actually known as the right hand screw rule, or also known as the Maxwell's corkscrew rule. Okay. So this is what is being given in this context. You can see the direction of A cross B, C is perpendicular to the plane. This is the first point, containing vectors A and B towards the advancement of the right-handed screw, rotated from A, first vector, to B, second vector, through the smaller angle between them, isn't it? So we are just trying to rotate it from A to B, isn't it? That's what they have given. First vector to B, second vector through the smaller angle between them. That's the angle in between A and B that's trying to say. Okay, yes, exactly, Pratik. So now thus, if this right-handed screw rule whose axis is perpendicular to the plane formed by A and B is rotated from A to B through the smaller angle between them, then the direction of advancement of the screw gives the direction of A cross B. So you can see that this n cap, the thumb is in what they are trying to say. They are just trying to say that n cap, which is the thumb, your thumb, everyone. Okay, thumbs up. Okay, thumbs up. It can be thumbs down as well. It can be thumbs down as well. Every time it's not going to be thumbs up. Okay, so thumbs down. Yes, same Murli, you are right. Direction of magnetic field lines can be also determined for circular current carrying conductors. Okay, and for straight current carrying conductors, it will be denoting the direction of electric current. In class 10th, you might have studied only the context of how to determine the magnetic field lines for a straight infinite current carrying conductor. But there are a lot of things in JEE main and advanced curriculum. I'm talking about the context of magnetic effects of current. We have to study it in class 12th itself. I think I've already mentioned about this in the introductory part, day 1, if you can recall. I mentioned about the syllabus associated with JEE main and advanced. So now this is what they are trying to say. They are trying to mention about that n cap over here. Okay. So now I hope it's clear. So now this is how a screw looks like, isn't it? So from that concept itself, it came. The Maxwell's corkscrew rule came from this screw. For example, you are having a nut, isn't it? And you want to fix that. So what you have to do? You need to use a screwdriver, isn't it? So as a result of that, you can see the sense of rotation is going to be clockwise. Then only you can fit the screw inside. And if I want to remove that screw from that hinge, let's say, or from any circuit, any type of entity, if I want to remove the screw from, then what I have to do? I have to rotate it in anti-clockwise direction, isn't it? Isn't it? Yes, exams, it's related to exams, Varshit. Exactly, you're right. So that's what this corkscrew rule is all about. You can see that there are two coplanar vectors A and B. So now the most important thing is that this A vector, B vector are coplanar in nature. Okay, they are coplanar with respect to each one of them. And this A cross B is denoting the direction of C. So I can say that C is equal to A cross B. That's what they're trying to say. So what are the examples? The examples are torque. I think so I have used this term for a couple of times. And last but not the least, velocity as well, isn't it? V is equal to omega cross R. We will be learning about this relation in between linear velocity and angular velocity. We are talking about this. This denotes the relation between linear velocity and angular velocity. Okay. This is a concept which is going to be taught in circular motion. And there are several such concepts. So that's the reason we are trying to know the basics of cross product in this lecture session of mine. Okay. So now let's get started. So R is the position vector and Fp omega. So we can see that here R is the position vector and Fp omega alpha, isn't it, are the force, linear momentum, angular. So they have just given you the annotations of the parameters which I am using it over here. There are other two examples. See, angular momentum, I have been using it for a couple of times, isn't it? J is R cross P. That is, what is P over here? That is the linear momentum over here. And acceleration, once again, this acceleration is known as the tangential acceleration. Okay, we will be learning this thing in circular motion, and rotation as well, it's going to be involved, tangential acceleration, isn't it? So now these parameters are very, very important. So these are some examples which I am trying to put it in front of you, because you must be thinking that, sir, why you are teaching this? Okay, it's not even required right now, isn't it? It's required, my friends. Everything, whatever I have been teaching in this bridge course is really important for each and every one of you. Okay, so now the next, I hope it's clear. If yes, give a thumbs up itself. Don't try to give a thumbs down, because it's really going to be difficult, isn't it? So I want a thumbs up from you guys. Okay, means denoting when the sense of rotation is always anti-clockwise. Okay, anti-clockwise thumbs up, clockwise thumbs down होता है, ठीक है? Okay, so yes, say everyone. These exams, okay, where these exams going on? What are you saying, Varshit? I am unable to understand. Which exams are you talking about? Okay, fine. Anyways, let's come to the next context. Okay, so these are some examples. So these are examples of vector product. So that's why we require them. Okay, so all these parameters you will be encountering in the context of class 11th JEE Main Advanced Curriculum Physics itself. Okay, so now we are going to be discussing about geometrical meaning of vector product. This is also very, very important question, and in the previous year JEE Main they have asked couple of questions which are going to be based upon this. So what is it all about? Consider two vectors A and B which are represented by OP and OQ. Okay, there are two vectors over here. Let's say I'm just trying to write it down. It as OP vector and OQ vector over here. If you're able to see in the diagram, OP and OQ vector. Angle POQ is being given as theta. Complete the parallelogram. We are just trying to complete the parallelogram. You can see that OPRQ represents a parallelogram. OP is equal to A, the same thing. OP is equal to B. Same type of concept we used, if you can recall, in order to add two vectors and try to obtain the expression of the resultant. But I am not going to be doing the same thing over here. Okay. So draw QN perpendicular to OP, isn't it? So that's what they have drawn. This is QN perpendicular to OP, and magnitude of cross product of A and B. So now what we have to do, A cross B, you can write it down. This is a very important note. So you can see that A cross B is equal to AB sin theta, which is OP OQ sin theta, which is equivalent to OP into NQ. OP into NQ. I hope you are getting this, OP and NQ. We are just trying to multiply them. So now you can say that area of a parallelogram, you know that is base into height. Everyone knows the area of a parallelogram. You people might have studied this thing in class 9 geometry itself, isn't it? So this is what is being given. So area of triangle POQ. So now you can see that this is how you can find out the area of a parallelogram, isn't it? OPRQ. So you can see that OPRQ, this is how we can try to formulate it, isn't it? Now the next thing is finding out the area of a triangle POQ. You know that what is the area of a triangle? We have already discussed this thing previously, if you can recall. In graphical representation, area under curve, I have used this for a couple of times. That area of triangle is half into base into height. So that's what I'm trying to do it over here as well. So you can see that base into height by 2. So OP into NQ. So OP is the base and NQ is the height, isn't it? That is half into A cross B. So this is the expression which you have to recall. We are having a couple of questions based upon this. So hold on your hats for a moment, for this moment itself. And the area of a, so these two formulas are very, very important. I will give these formulas as 1000 stars worth over here. This one and this one, area of a parallelogram, OPRQ is 2 into area of triangle OPQ, that is, this is also 1000 stars. So now that's how, if you are being given two vectors, in order to find out the area of a triangle, we need to perform A cross B, isn't it? Area of a parallelogram has to be done by A cross B, and area of a triangle, you just need to include half term before the modulus of A cross B. Okay, I hope it's clear, everyone. If yes, give a thumbs up. Hit the like button, everyone. So let's proceed to the next context. Now we will try to learn how to perform cross product. Okay. So there are some rules associated. So you can see that these are the formulas you have to remember. The formulas which you need to recall. So I will say that to remember. These formulas you need to remember. The same formulas, isn't it? Half into A cross B for the area of a triangle, and for a parallelogram it has to be A cross B. Okay, and if the diagonals are being given, see now there is an extra formula over here. If the diagonals are being given, then the area is going to be half into A cross B. Okay, so now these three formulas are very, very important. You should be noting down in the notebook which you are following right now in front of you, isn't it? What happened, Toman? Okay, so now this is how we need to follow these rules in order to find out the area of a parallelogram, area of a triangle. But yes, if they are going to be giving you A and B in vector forms, then only we can do it like this, isn't it? So now let's go to the next context, that is vector product of two vectors. So you can see the same thing we are trying to say, but I will be explaining something very interesting over here. Now dot product, addition of two vectors, they were following the commutative, they were commutative with respect to each other, isn't it? Commutation, if you can recall. Cross products are not commutative in nature. They are non-commutative in nature. Okay, so what they are trying to say is vector product of two vectors is always vector perpendicular to the plane containing two vectors that is orthogonal, perpendicular to both the vectors A and B, isn't it? So you can see that C is perpendicular to both A and B, so that's what they are trying to say, that it is orthogonal in nature. Okay, vector product of two vectors is non-commutative. This is what I was trying to say. What is it? A cross B is never, never, ever going to be equivalent to B cross A. Okay, if you can recall, in the previous case, if we discuss about addition of two vectors, I said that A plus B is equals to B plus A, isn't it? And similarly, yesterday when we were discussing the dot product, I also mentioned that if I am going to write down A dot B, that can be written as B dot A, isn't it? But this, in this context of vector product, you cannot say that this is going to be B cross A. Because now I will mention what is going to be the exact annotation which is going to be used over here. So I can write it down that A cross B, you can see that we can write it down A cross B as minus of B cross A. So always remember one thing, A cross B is equal to minus of B cross A. That means what is the difference in between them? So let's say A cross B is giving us C vector, and let us say B cross A is giving us some D vector. C and D will be anti-parallel vectors with respect to each one of them. They are negative vectors to each one of them. I hope you understand negative vectors. That's what I'm trying to say. Okay. So C is going to be equivalent to, you can say A cross B is going to be minus of B cross A. So in case of vectors A and B, our magnitudes are equal, but the directions, this is what I'm trying to say, directions are opposite. So if I'm saying that C vector, A cross B, as a result I'm getting this. So B cross A has to be equivalent to minus of C vector. Okay, minus C over here, we are not getting something as negative. This negative sign denotes the sense of rotation. So let's say A cross B was depicting a vector while the sense of rotation was anti-clockwise. Now B cross A means we are just trying to change our sense of rotation. As a result of that, we are getting a thumbs down, isn't it? Thumbs up, C vector, thumbs down, minus C vector. C vector minus C vector are negative vectors of each one of them. Okay, so that's what I am trying to say. I hope it's clear. Say Toman. And what else? Who else are there? Okay, so now let's proceed over here you can see that the vectors, so now some other properties, there are lots of properties over here, okay. So now in this case it's being given that the vector product is distributive, isn't it? The vector product is distributive when the order of the vectors is strictly maintained, that is A cross B plus C is going to be written as A cross B plus A cross C, isn't it? So this is how you can write it down. A cross B plus C is going to be equivalent to A cross B plus A cross C. So according to the definition of vector product of two vectors, A cross B is going to be AB sine theta n cap, and theta is going to be sine inverse of A cross B by AB, isn't it? Now the vector product of two vectors will be maximum when sine, you know that. What is the maximum value of sine? You know that the maximum value of sine theta is 1, isn't it? And at what angle are you supposed to obtain the value of it as 1? That is 90 degrees, isn't it? Or pi by 2 radians. This is what they are trying to say, isn't it? So over here you can see that sine theta is equal to sine inverse of A cross B by AB. That's what they are trying to say. And the value of theta is 90 degrees. So you can say that A cross B max is equals to AB sine 90 is equal to AB. So the same thing we are going to be implying. With the same thing we are going to be implying to find out the maximum value of torque, the maximum value of angular momentum, the maximum value of angular impulse, the maximum value of linear velocity, the maximum value of tangential acceleration, isn't it? So this is what we are trying to say over here, okay? So now you can see that the vector product is maximum if the vectors are orthogonal, which is perpendicular, which I have already mentioned. The vector product of two non-zero vectors will be 0 when theta is going to be 0, when you can say A and B are parallel or anti-parallel with respect to each one of them, isn't it? So you can see that will be 0 when sine theta is 0 or theta is 0 or 180 degrees. So A cross A is 0 and A cross minus A is 0. So I will mention, so over here as well, the unit vectors, if they are going to be underwent with the operation of cross product, will be giving us some different results as comparative to whatever we have studied yesterday. Whatever we have studied yesterday, right? If you can recall, we discussed about dot products. I cap dot I cap was giving us 1, isn't it? J cap dot J cap was giving us 1. But this time, in this context, I cap cross I cap will be giving us 0. Okay? And what I cap cross J cap is going to be giving us, we will try to find it out in the upcoming context. Okay? So now therefore if the vector product of two non-zero vectors is 0, then the vectors are collinear. This is also a very important statement which I have mentioned it over here, isn't it? So then the vectors are going to be collinear with respect to each one of them. I hope it's clear, everyone. I hope you are following. Those are following, then they can ask something over here. Okay. So now the next slide, please. Okay. Very good, Jashwant. Great. Okay, so now let's try to focus over here. The self cross product, that is product of a vector by itself, is 0. So that's what we are trying to say, that A cross A is going to be AA sine of 0 degrees over here, which is 0. In case of unit vectors, so this is what it is, n cross n, isn't it? That is 1 cross 1 sine 0 will be 0. So I cap cross I cap is 0. J cap cross J cap will be 0. K cap cross K cap will be 0. So these things are very, very important to understand, isn't it? So in the previous class, if you can recall, we mentioned I cap dot I cap is 1, J cap dot J cap is 1, K cap dot K cap is 1. But now, right now, isn't it? It is going to be J cap cross J cap is going to be equal to 0, and K cap cross K cap is going to be equivalent to 0 over here. So that's what we need to do it over here. Okay. So now the next is, yeah, hello everyone. Okay. So now let's try to follow over here. In case of orthogonal unit vectors, I, J, K, according to the right hand thumb rule, we have to find it out, isn't it? So this rule you need to recall, isn't it? See now how to determine what is going to be the values associated with I cap cross J cap, isn't it? J cap cross K cap and K cap cross I cap, or just the vice versa. We are choosing a single direction of rotation over here. What is the direction of rotation? That is anti-clockwise. We are treating anti-clockwise to be positive, isn't it? We are treating anti-clockwise to be positive and clockwise to be negative, isn't it? There are two aspects, clockwise, anti-clockwise is positive, isn't it? And clockwise is negative. Why anti-clockwise is positive, everyone? The reason is that the rotation of the earth along its own axis is anti-clockwise. So that's the reason. I don't know, Varun. Okay, on 10th I think so. Okay, so now you can see over here that anti-clockwise is plus, clockwise is negative. So I cap cross j cap gives you k cap. Dikh raha hai na? I cap cross j cap gives you k cap. Then k cap cross I cap, if I go in this direction, isn't it? I will be getting it as j cap. Then it's being given that j cap cross k cap in this sense is going to be giving us I cap. And if I just try to go it in a different way, means if I just try to perform I cap cross k cap, that has to be minus of j cap, isn't it? So this is what is being given. I cap cross k cap is minus of j cap. Similarly, if I try to perform j cap cross I cap, so this is the sense of rotation. The sense of rotation is becoming clockwise over here. As a result, I will be getting j cap cross I cap will be minus of k cap. And now if I just try to perform k cap cross j cap, once again, against means in a clockwise sense, so I will be getting it as minus of I cap. So the sense of rotation is very, very important over here, isn't it? So if you are being asked to try to find out the cross products in between them, you can use this Maxwell's corkscrew rule itself. This is the other name which I am using it for, Maxwell's corkscrew rule. Okay, that's what this context is all about. But there is some other shortcut method as well to find out the cross product, which I am about to mention to you right now. Okay, so what is that method? Let's try to find it out. Okay, so now you can see this is the method which I am trying to mention about. Okay, so with the question we can try to find out this rule. This rule which is being given, okay, by using Ax, let's say A vector is Ax I cap plus Ay j cap plus Az k cap. The same thing I did it yesterday, if you can recall. And B vector is being given as Bx I cap plus By j cap plus Bz k cap. So the same thing I'm just trying to solve, but this time it's going to be cross product. Okay, so now what needs to be done? So this is the formula. There is no need to recall the formula. If you want to recall the formula, you can, but there is a very interesting way to do so. So I will be doing it by the means of a question. Okay, this will be proven to be solved, you can say, by the means of a question. Okay, by the means of a question. It will be clear to you. How we are getting it, I will mention it. Okay, I am just trying to, okay, let's see that I am trying to mention you right now itself. Okay, let's say that I will trying to solve this over here. Let's say that let A vector, you can write down Ax I cap plus Ay j cap plus Az k cap. And let's say B vector over here is being given as Bx I cap plus By j cap plus Bz k cap. So now we are having A is equal to Ax I cap plus Ay j cap plus Az k cap, the three components, you know that. And B vector is having the three components which are Bx I cap plus By j cap plus Bz k cap. Okay, this is what online class is going on for basic, Varun. Okay, so now we can do A cross B is required to be found. There are two methods. One, if you are going to be using this method, which method are we talking about? This, using the corkscrew rule. Write down properly and then try to perform the operation. But it will be time taking. You must be thinking that, sir, how are you going to take I cap cross j cap and j cap cross k cap, isn't it? So that will be quite difficult for you. So that's why we are going to be using the determinant rule. See, this is going to be found. This expression which is being written over here in the form of a theory, it's just an expression which is being given the form of a theory, but actually it's not a theory. You need to use this to solve cross products associated between two vectors. So what we are going to do over here is, now you are having, let's say, A cross B is required to be found. So now what you will do, you have to construct a determinant. That's known as determinant, everyone. So I will write down, what is this? This denotes a determinant. And determinants is going to be taught in the JEE Main Advanced Mathematics curriculum as well, if I say. But once again, we physics teachers, we need to teach you before mathematics sirs does. Okay. So now what I am going to do is, first of all, write down the unit vectors I cap, j cap, k cap. Okay, first of all, I am writing down the unit vectors I cap, j cap, k cap. And if I want to perform A cross B, then we need to write the coefficients of I, j, k in the second row. Okay, so these, always remember one thing, the one which I am writing it down over here, this is going to be known as the first row. The group of elements whichever I will be writing down over here, they will be known as second row. And the group of elements whichever I will be writing down beneath the second row will be known as the third row. So now we are having three rows over here, first row, second row and third row. Similarly, so now what we have to write down, let's try to write down the coefficients over here. Coefficients, we are trying to perform A cross B, so the coefficients of A vector needs to be written prior to B vector. So that's why I will be writing it over here as AX, isn't it? AX, AY, AZ. Everyone whomsoever are studying, who are really interested, okay, for JEE Main Advanced, okay, they should be following it right now, regardless of interacting amongst each one of you, okay. So now it's going to be AX, AY, AZ. I wrote down the coefficients. These are the coefficients, right, if you're able to see. We are writing down the coefficients, isn't it? AX, AY, AZ in the second row. Now, what needs to be done? We need to write down the coefficients of B, which are BX, BY and BZ. Like this. Such that now if these are known as rows, in any determinant, any matrix, you will be able to find out that the horizontal elements which are being written are going to be known as rows and the vertical elements are going to be known as columns. So what we can write down, this is going to, that means we can say this is going to be your first column, isn't it? This is going to be the first column, this is going to be the second column, and this is going to be the third column. So now we are having three columns over here, okay? Three columns, three rows. This is a 3 into 3 determinant. Now what needs to be done? Now we have to think what is required to be done. So can anyone tell me what needs to be done? No, Jayavant, vertical lines are not rows. You are just saying the vice versa, okay? The horizontal has to be row, the vertical has to be columns, okay? So now what we are going to do is, over here, first of all, write down I cap over here, isn't it? I cap. Now what you have to do is, you have to do it in a very interesting way. First of all, hide the components, the elements which are situated beneath I cap, like this. Now you are left behind with this AY, BZ, AZ, BY, isn't it? Now cross multiply, starting from the left, okay, like this. AY, what we can write it down? We can write it down over here as, let's try to hide it. We are just trying to hide it, everyone. So we can write down it as AY, BZ, isn't it? After hiding it, I am writing it down as AY, BZ, okay. Now minus of BY, AZ. Along with, so what do we have to write down before I cap? Actually, according to maths, it's being written as -1 to the power of sum of the row plus the column. They are trying to mention the position. M and N are the position of that element in that determinant. So I will write it down over here as -1 into M plus N. So what is M and N over here? So what we can write it down in this case? So you can see that in this context we are having AX. You can see for this it's going to be what? This is first, second row, first column, isn't it? M is 2, N is 1. So I will write it down it as -1, isn't it? Okay, just give me a moment for this one. We are talking about this I cap, isn't it? So what we will write it down? This is first row and first column, isn't it? 1, 1. So that's why, what are we writing down exactly? We are writing down the factors associated over here. You will be learning this as your co-minus co-factors, isn't it? Over there, once you are going to be taught with the concept of determinant, okay? So we can write it down it as -1 to the power of 1 plus 1. this. Okay. Now, plus minus 1 to the power. Now we have to write it down for j cap, isn't it? So j cap, can you determine the location of j cap? That is what we are having. This is first row, second column, isn't it? First row, second column. So what I will write it down? Minus 1 to the power of 1 plus 2, j cap. Now hide the elements which are beneath j cap over here, like this. So what we are having? We are having the diagonal elements needs to be chosen, right? Ax into bz. So I will write it down like this. Ax into bz, okay, minus of ax into bz, minus of what? Bx into az. Now, for k cap, can you identify the location of k cap? If yes, write it down over there in the chat box, everyone. So this is going to be what? Minus 1 to the power of. Let's try to determine the location. Now over here we are having first row, third column. First row, third column, isn't it? M stands for the row, you can say mth row. And we are having n to be the nth column over here. Now what we will write it down? Minus 1 to the power of 1 plus 3, isn't it? K cap. Hide the elements which are beneath k cap, isn't it? So what we are going to do? Ax into by, isn't it? Yes, correct. Ax into by. From the left we have to do ax into by. This is being cross multiplied, isn't it? Minus of this, which is minus of bx ay. This is how you can find out the cross product in between two vectors. Okay. So now let's try to solve it furthermore. So this can be written as what? What is 1 plus 1? 2, isn't it? So minus 1 square, this is going to become. So minus 1 square is going to be 1 itself, isn't it? So as a result, I will be getting this as, you can write down ay bz, isn't it? Minus by az, isn't it? Minus 1 to the power 1 plus 2 means minus 1 to the power 3 is coming over here. So I will write it down it as minus 1 to the power 3 ax. Okay, j cap is there, right? This is I cap. Don't forget the unit vectors, they are very, very important. This is ax bz minus of bx az, isn't it? Now plus over here we are having minus 1 to the power 1 by 3. What is 1 plus 3? 1 plus 3 is 4, isn't it? So we can write it down it as minus 1 to the power 4, isn't it? K cap ax by minus bx ay. So now can you tell me what is minus 1 square? Write it down over there in the chat box, everyone. What is minus 1 square? Let's see. What is, everyone, minus 1 to the power 4? Tell me about it. Okay, 1. Very good. So now you will be getting, now if I solve it, you will be getting this as, what I will be getting? Directly you can say ay bz, isn't it? Minus of by az. What is minus 1 to the power 3? Minus 1 to the power 3, write it down over there in the chat box, everyone. What is minus 1 to the power 3? Waiting for you guys. Minus 1, very good. So that is minus of j cap. See, so always remember one thing. So that's the reason j cap is always denoted with a negative sign. Okay? I am just doing the derivation over here, but actually minus j cap you need to write it down every time. I cap and k cap. Plus is fine, but for j cap we need to associate it with a negative as its prefix. So I can write it down as minus j cap ax bz, isn't it? Ax bz minus of bx az plus what I will be getting? What is minus 1 to the power 4? Write it down over there in the chat box. What is minus 1 to the power 4, everyone? What I will be getting? That is 1, isn't it? So k cap over here, that is ax by minus of bx ay. So this is going to be the answer to this. Means if you solve this, you will be getting this. So let's try to check this thing, everyone, isn't it? Over here, Right, see, AYBZ minus AZBY, isn't it? AYBZ minus AZBY, isn't it? Just change the sequence. Next over here we are having this as okay. Next we are having it as, you can see that minus of J cap, see the minus sign they have given it over here, AXBZ minus AZBX, isn't it? AXBZ minus AZBX or BXAZ, whatever you can write down. It's product itself, isn't it? And now we are left behind with this. That is AXBY minus AYBX, isn't it? So you can write it down over here. AXBY minus AYBX. Henceforth proven, isn't it? So this is the entire process required. So whenever you're having, just remember I cap minus J cap and K cap while writing down. Hide the components. If I try to write down I cap, you need to hide down the components which are beneath that unit vector and then try to cross multiply it from the left, and then minus of the diagonal elements needs to be cross multiplied from the right. Like this you have to keep on doing it. Okay, I hope it's clear everyone. If yes, give a thumbs up, hit the like button, and then let's try to solve this question. Okay, this is a question everyone. It's a very simple question. F is equal to 4I cap minus 10J cap, R is equal to 5I cap minus 3J cap. Calculate the torque. Tau is equal to R cross F. So now this is the real life a ground application over here, what we are trying to do. So we can write it down over here as what we have to do, I cap, J cap, K cap, isn't it? This is torque we are trying to find out, isn't it? So now what we have to do everyone, okay, so what we have to do in this context, okay, dekhte hain, kya aa raha hai? Write down the answer over there in the chat box everyone. Write down the answer over there in the chat box everyone. What do you think? 38 K cap. So let's say, first of all, R cross F, that means the vector, you can say that R components needs to be written in the second row, isn't it? So that's why I will be writing it down it as what? 5I cap minus 3J cap is there. 5, are you able to see any unit vector associated with K cap? No. So I will write it down it as 5 minus 3, 0. I hope it's clear how I'm writing down the elements. 5 minus 3 and 0 over here, isn't it? 5 is the unit vector associated with I cap, minus 3 with the J cap, and K cap, no unit vectors along the K cap direction, so that's why it's 0. Okay, now for force I will write it out, it is what? 4 minus 10. Once again the force vector as well, it is not having any components associated along the Z axis, isn't it? So that's why what we are going to do, we have to write it down it as 0. Very good. Dekhte hain answer kya aa raha hai. So now what we have to do is, you have to write it down like this, I cap, hide the elements like this. What we are having? Minus 3 into 0, isn't it? Minus 3 into 0, minus 3 into 0, everyone, isn't it? Minus of minus 10 into 0. Hardly matters because anyways I will be getting 0 itself. Okay? Then minus J cap. I am not using minus 1 anymore, isn't it? I am not using minus 1 anymore because it's already been given over there, isn't it? So what I will be getting? I hope it's clear everyone. So now for J cap, hide the elements which are beneath the J cap. We'll start with 5 into 0. From the left, 5 into 0. Minus of 4 into 0, isn't it? Like this for J cap. Great. Now in the end I will be having K cap. So you can see that, isn't it? K cap, from there itself you can make it out that I cap J cap will be vanishing. I cap J cap will be vanishing in the end, isn't it? So what I will do, hide the K cap side. What we are having? 5 into minus 10, isn't it? 5 into minus 10 like this. Minus of what we are having? 4 into minus 3. So what are we going to have everyone? I hope it's clear. If yes, give a thumbs up. If it's clear, give a thumbs up, hit the like button, isn't it? तो क्या आना चाहिए? Everyone, write down the answer after solving it. Sri Bindu, minus 38 K cap. 38, 64, whatever you are getting. So now this will be 0, isn't it? 3 into 0 is 0, 10 into 0 is 0. So everything, all the entire expression will become 0. 5 into 0 is 0, 4 into 0 is 0. The entire expression will become 0. Now we need to solve only this part. This part needs to be solved. Then what are we going to do? What are we going to do, everyone? So this is going to be k cap, isn't it? 5 into minus 10 is minus 50, isn't it? 4 into minus 3 is minus 12. So it is going to become minus 12 like this. Minus 50 plus 12. Kitna aata hai? That is minus of 38 k cap is the answer to this question. So the torque is along the negative direction of z axis, isn't it? Newton meters, don't forget to write down the units, but you don't know, unfortunately, you don't know torque, and I haven't started units and dimensions yet. Units and dimensions will be started on Friday, isn't it? Isn't it, Sameer? It's correct itself, that is minus 38 k cap. So I hope everyone got the answer. If yes, hit the like button and give a thumbs up, means it's a torque. But this time, in this case, the thumbs are going to be down. If this is a perpendicular plane, let's say, or let's say, आपका कोई भी ये आपका blackboard है, ठीक, and let's say anything is rotating. Let's say something is rotating in a clockwise direction. I am getting the torque inside the blackboard. That's what it's trying to say. ठीक है? That is what they are trying to say. Yes, correct, Venkateshwara. सही जवाब, minus 38 k cap. Okay, so if yes, then if you have understood this, you can. I hope it's clear, everyone. So let's try to solve this. Try to solve it as your homework. That's thumbs down, that's fine, home foodie. Its torque is definitely, it's clockwise, so niche lag raha hai, minus. If I say that this is the z axis, then definitely Shiba, Miyuki, they are correct. Okay, anyways. So mark it as homework, everyone. This is your homework. I will solve it tomorrow. Okay, so what they are saying, you need to find out the cross product. You need to find out the cross product over here, and then you need to find out the unit vector. Unfortunately, Kavita, I don't know that language. Okay, I hope you got it. So now that's it for today. So tomorrow we are going to be solving some questions. देखिए बहुत सारे questions है. Lot of questions are required to be done. So tomorrow is going to be, for 2 days we are going to be having problem solving sessions. So today your vectors completed, means your vectors, the entire theory part of vectors got completed. We are having lots and lots of PYQs and some basic questions which we are going to be solving into the next class. Okay. Anything else you want to say, you can mention it to me. Okay, so anything you want to ask it from me, you can ask, and let's have some motivation session right now. Anyways, we are having certain time left until and unless Maths sir joins the class. College is going to be opening after 10th. Okay, so college is going to be opening after 10th, isn't it? What else you want to ask? Why? Why, Hinata? What happened? That's a difficult one. I can't recall, but because I watched Pushpa 2 in Hindi itself. So actually I cannot say, even if I say that, but it won't be that good to enunciate any dialogue right now. Right, isn't it? Okay, fine then. That's it for today. Thank you very much. It's Avinav Banerjee for you. We'll be back once again at 4 p.m. for tomorrow's session, and we'll be solving some problems based upon dot products, cross products, and addition, subtraction, resolution of vectors. So it will be miscellaneous problem solving session which is going to be conducted for 2 days. That's today and for tomorrow. So departing right now, hit the like button as much as you can. Share this lecture sessions to your friends such that they can get enlightened by Sri Chaitanya Educational Institutions. And don't forget to subscribe our Sri Chaitanya Educational Institution channel.